Hey guys, in this video we're going to look at the third method for solving systems of equations, and that is the elimination method. This is typically the one that is most preferred by algebra students. It should be a review from last year, but we'll just go through a few examples to quickly jog your memory. So for the elimination method, the first thing you want to make sure is that your equations are lined up, meaning that your x and y terms are lined up and your constant terms are lined up. Typically, you'll see your equations written in standard form for that, but as long as all the terms are lined up and on the same side of the equal signs, you can do this method. So the first step is to make sure you have opposite, once you've lined up, the first step is to line up. The second step is to make sure you have opposite coefficients on one of the variables. So for number one, I have that. We have a positive 2y in the first equation and a negative 2y in the second equation. So if this is already done, then you can skip ahead to step 3 and you simply add the equations together to eliminate that variable. And so if we add these two equations together, 2y and negative 2y will cancel each other out, and we get 8x equals 64. So now I can just solve this equation, 8x equals 64, and I see that x is equal to 8. Well, once we have our first variable, we then substitute that answer back into one of the original equations to get the second variable. So I can take my first equation, 3x plus 2y equals 22. And now that I know that x is equal to 8, I can put my 8 back in for x and solve for y. So this gives me 24 plus 2y equals 22. 2y would therefore be negative 2, and y would be negative 1. So the solution to this system is the ordered pair 8, negative 1. Okay, number 2, if you look at this system, you see that we do not have opposite coefficients, and so we need to take a look at this step 2 here. And step 2 says to multiply one or both equations by a number to result in a variable with opposite coefficients. So this is where least common multiples come into play. You need to find either the least common multiple of 7 and 2 on your x terms, or the least common multiple of negative 6 and negative 3 on your y terms. In this case, it's probably easier to do negative 6, negative 3, and our job is to get both of these coefficients on the y's to be a 6, preferably one a negative and one a positive. Why are we choosing a 6? Well, the least common multiple of 3 and 6 is 6. So that means I can multiply one or both of these equations by a number in order to make these both 6's. Since we already have a negative 6y here, I'm going to leave the first equation alone, and I'm simply going to look at my second equation, and I'm going to multiply everything in that second equation by negative 2. I'm multiplying by negative 2 because I want to make this coefficient positive in order to have opposite signs on my y variables. So when I multiply everything in this second equation by negative 2, I get the following. Negative 4x plus 6y equals positive 26. My top equation I'm leaving the same. 7x minus 6y equals negative 53. And now I can use elimination by adding these equations together and getting rid of my y terms. So 7x minus 4x is 3x, and negative 53 plus 26 is negative 27. So we have 3x equals negative 27, and therefore x is negative 9. So now I need to go back. I need to substitute negative 9 in for x into either one of my original equations. I'm going to choose my second equation this time, just because those numbers are a little bit smaller. So 2 times negative 9 minus 3y equals negative 13. I'll need to add 18 to both sides, and that gives me negative 3y equals positive 5. And then if I divide both sides by negative 3, I get y equals negative 5/3. So my ordered pair for this system is negative 9, comma, negative 5/3. Okay, number 3. 5x plus 3y equals negative 7, and 2x plus 7y equals 3. So this time I'm going to have to multiply both equations in order to get opposite coefficients, and my choices are either the 5 and 2 on the x's or the 3 and 7 on the y's. Well, I know the LCM of 5 and 2 is 10, so I'm going to choose the x's to eliminate in this case. So that means my top equation I can multiply by negative 2, and my bottom equation I can multiply by positive 5. I could have also multiplied the top equation by positive 2 and the top equation by positive 2, the bottom equation by negative 5. As long as you're getting opposite coefficients, it doesn't matter which one's getting the negative here. So negative 10x minus 6y equals positive 14 is my top equation. 10x plus 35y equals 15 is my bottom equation. So my x terms eliminate. Negative 6y plus 35y gives me 29y equals 29, and that means y comes out to be 1. I take one of my original equations, and now I substitute a 1 in for y. So if I use the bottom equation, that would be 2x plus 7 times 1 equals 3. So I get 2x plus 7 equals 3. 2x would be negative 4 then, and x would be negative 2. So this ordered pair is negative 2, 1. Okay, last one. 5x minus 6y equals 3, and 7y equals 2x plus 8. So in this problem, my terms are not lined up, so that's the first thing I need to do is rewrite these so that my like terms are lined up in both equations. So the first equation is fine. I'm going to leave that as 5x minus 6y equals 3. The second equation, I just need to subtract 2x from both sides to put it back on the left side. So that's going to be negative 2x plus 7y equals 8. Okay, so now my choices are 5 and negative 2 or negative 6 and 7. Well, I'm going to look at my x's again since we just did that, and I'm going to multiply the top equation by 2, the bottom equation by 5. I don't need to multiply by a negative here because I already have opposite coefficients. So top equation, positive 2, bottom equation, positive 5. I end up getting 10x minus 12y equals 6 then for my top equation, and the bottom equation, negative 10x plus 35y equals 40. So I eliminate my x terms. I get 23y equals 46 here, and so y is equal to 2. And now I take one of my original equations. Let's take the second one. 7y equals 2x plus 8, and I substitute a 2 back in for y. So this would be 7 times 2 equals 2x plus 8. I get 14 equals 2x plus 8. Subtract 8 from both sides, I get 2x equals 6, and so therefore x is equal to 3, and my ordered pair is 3, 2. Okay, if you had any questions over this video, make sure you ask those the next time I see you in class, folks. Until then, have a nice day. You're all wonderful people.